heard of the binomial theorem, and it's actually pretty cool. Okay, well, I think it's cool, but you know. Okay, so we're going to title our notes Binomial Theorem. And our target, describe the process for using the binomial theorem. All right. Y'all know what a binomial is, right? A binomial, what is it? Two terms. One term is a monomial. Two terms is a binomial. Three terms is a trinomial. You know what four terms is? Polynomial of four terms. What is five terms? Polynomial of five terms. Six terms. Polynomial of six terms. So only a monomial, binomial, and trinomial, they are the only ones with special names. Everything else is a polynomial with however many terms there are. So the binomial theorem, say I have x plus 2 quantity raised to the fifth power, and I wanted you to simplify that. You would have to do x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. Multiply all of that out to get an answer, right? That would be simplified. Well, the binomial theorem is very cool because it will help us. Well, we're going to use the Pascal triangle to help us do that, expand that binomial without doing all of that multiplication. Okay? So, the binomial theorem is a quick way of expanding by expanding, I mean multiplying a binomial expression that has been raised to some power. So, for example, 3x minus 2 quantity raised to the 10th power would be very time consuming to multiply by hand. The formula for the binomial theorem is as follows. what in the world is all that stuff? So basically that's saying when you have an exponent of n, that's what this is, and k is equal to 0, so highest value is your exponent down to 0, your first term would be your exponent minus 0 times the second term raised to the 0. What does that mean? Don't worry. We're going to use Pascal's triangle to help us. Okay, we're not actually going to use the actual theorem. We are using the actual theorem, but we're also using Pascal's triangle, so it's way easier than it looks. Okay, it can get a little detailed, all right, but it's that seems crazy. Don't turn your brain off and ignore me because it's really not that bad. So I'm going to say, however, we will use Pascal's triangle to help us expand a binomial. And y'all will have to memorize Pascal's triangle. Have y'all ever heard of Pascal's triangle? Huh? About 30 seconds ago. Me too. Just kidding. All right, so the first example I'm going to do it by hand like we normally would do it by hand, okay? So we can compare it for after we do Pascal's triangle. Are you looking for the key, ma'am? Yes. So that's fine. Okay. I got it. All right, for you. I just wanted you to know so that you knew in the future that it didn't work. But I kept it safe. Okay. So let's expand a plus b quantity raised to the fourth using distribution. And that's nothing new. We already know how to do that. So is a plus b raised to the fourth, is that a to the fourth plus b to the fourth? Oh, thank goodness. No, there's a lot more stuff that's going to go there besides a to the fourth plus b to the fourth, right? So if I'm going to expand it using distribution, this is what we already know how to do. We know that a plus b raised to the fourth is the same thing as a plus b times a plus b times a plus b times a plus b, right? And I can only multiply two binomials together at a time. So let's just do a plus b. We'll multiply two at a time, and then we'll see what we get. Multiply that together. And really, isn't that a plus b quantity squared? Yeah. So if I wanted to, I could rewrite this as a plus b quantity squared times a plus b quantity squared, because we know a shortcut. When we have a binomial squared, we know a shortcut to that, don't we? So we can make it a little bit easier. So let's just do one of them at a time. So a binomial squared, the shortcut, my first term squared is what? A squared. The next term, you multiply what's in parentheses and double it. So a times b, ab doubled is 2ab. So plus 2ab. And then to get your last term, you square the last term. So b raised to the second power is b squared. So the second a plus b quantity squared is going to be the exact same thing. Now we got to multiply all of that out, okay? So I can either distribute or I can do my box method. I'm going to do the box method. It doesn't matter. We'll get the same thing. I just feel like the box method really helps to keep it all organized. All right, multiply. A squared times a squared is a to the fourth. What's a squared times 2ab? 2a cubed b, very good. 2a cubed b. A squared times b squared would be a squared b squared. I'm going to use a lot of colors here. I don't know if changing colors is necessarily the best. 2ab times a squared. 2a cubed b. So that has a like term. I'm going to do that pink. 2a cubed b. 2ab times 2ab. Or a squared b squared. So that's going to be the same as what I had in orange already. Well, same. It's going to be like term. Except for the 2 with it. Or for this. 4a squared b squared. What's 2ab times b squared? 2ab cubed. Okay. B squared times a squared. Let's do a squared b. You could say b squared a squared, but we already have, isn't that the same as a squared b squared? And since we already have it as the a first, let's do that so we don't get confused. B squared times 2ab. 2ab cubed. B squared times b squared. B to the fourth. Let's use red. Okay, combining like terms. A to the fourth has my highest degree, and there are no other a to the fourth, so nothing to combine it with. Sorry, I dropped my pen. This one's I'm starting with a's. I'm going to go in order where I'm going to go like a to the highest degree, a to the next highest degree. So a to the fourth. So next I'm going to combine the terms that have the a cubed b. So 2a cubed b plus 2a cubed b would be what? Plus 4a cubed b. When we're adding, we only add the coefficients, not the variables. And then I'm going to combine the terms that have the a squared b squared. So a squared b squared plus 4a squared b squared plus a squared b squared would be what? Plus 6a squared b squared. Very good. Then I'll do my green ones. 2ab cubed plus 2ab cubed is 4ab cubed. Then that b to the fourth, we got nothing. So not that that was difficult, but a little bit time consuming and a little tedious. And lots of places to make errors, right? So say I gave you this problem on your test and you're like, I do not remember Pascal's triangle. I don't know. Well, you could always still multiply it out. I'm like, you're still going to get the right answer if you multiply it all out. But if you know Pascal's triangle, and if I give you a plus b to the 10th power, and you know Pascal's triangle, make it a lot easier. And you're like, well, what is Pascal's triangle? Well, I'm going to show you on the next page. I just wanted to do this one the way we already know how to do it, then show you Pascal's triangle and how we could find the same answer using Pascal's triangle. Y'all down with it? Great. Oh, notice any sort of patterns here. Look at your A's. We got a to the fourth, a cubed, a squared, a, no A's, right? Look at your B's. No B, B to the first, B squared, B cubed, B to the fourth. That's interesting. So the first term had 4 degrees, and notice a plus b was originally raised to the fourth and went 4, 3, 2, 1, 0. Because a to the 0 would just be 1, we wouldn't put an a in there, right? And then the b's, we had the highest b, b to the fourth, which is our second term, is all the way to the end. We go 4, 3, 2, 1, 0. So b to the 0, there's no b's in the first term. That's interesting. Do you think that happens a lot? It does. Okay. Just a little hint. We can use Pascal's triangle to help us expand a binomial without distributing. Here is a pattern that we will need to memorize. You will also need to memorize Pascal's triangle. Don't worry, it's not hard. No, we're not using it at all. We're using Pascal's triangle. I mean, we're using that theorem. We're just not like plugging it into the theorem, but we're actually using it. All right, so Pascal's triangle, you have to memorize it. It is a pattern as well, okay? We're only going to go to like 7 or 8 layers in, but it can keep going on and on and on and on and on and on. So Pascal's triangle is kind of like in the shape of a triangle, okay? The very top, there's a 1. That's easy. The second layer, there are 2 1s. Kind of like place them on the outsides because we're going to be forming like a pyramid, okay? Pyramid. You always, on the outside, there's always going to be 1s on the left side and the right side, okay? So the next one, we're going to start with a 1. And then we add the 2 numbers together above it. 1 plus 1 is 2. And then we have a 1 on the outside. The second layer, we start with a 1. We add 1 plus 2 is 3. 2 plus 1 is 3. And then put a 1 on the outside. The next layer, 1 on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 on the outside. The next layer, 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 on the outside. See, it's pretty easy to memorize, right? You just got to do it in your head. Next layer, 1 on the outside. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. 1 on the outside. Let's do one more layer. 1 on the outside. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. 1 on the outside. And it's kind of important that how you write it out so you don't get confused. Like, wait, what am I adding? If you have everything all squished together, like See how I kind of like went in between? It was easier to tell what I was adding. So my Pascal's triangle will only go up to a binomial raised to the 7th power. If I need it raised up to the 8th power, I need to do another layer. If I need it raised to the 9th power, I'm going to need to do 2 more layers, okay? So this number here, so this would be if it's squared, cubed, 4th power, 5th power, 6th power, 7th power, okay? So if I want to do 8, I'll just put in another row. If I did, that would be 1, 8, 28, 56, 70, 56, 28, 8, and 1. Did I mess it up? I did it in my head, and I am not the best mental math person, even being a math teacher. Back in my day, we didn't learn mental math. We just learned how to do everything on paper. Not a calculator, but on paper. So mental math is not my strong suit. So did I make any mistakes? Okay. So
not the one, but the one
next to it.
next to the one.
Yeah. So see how it goes? None of the other ones would go in order. So 1, 2, 3, 4, 5, 6, 7, 8. See, none of the other ones do that. So look at that row. So if I want it to the 8th power, I use this bottom row. We're going to do the one we just did on the previous page. So we're going to do to the 4th power. So 1, 4, 6, 4, 1. So let's write example, expand a plus b to the 4th using Pascal's triangle. Okay, so the numbers from the triangle are your coefficients of each term. They may change depending on the problem, like once you multiply stuff out. But when you initially start, these numbers, so we're 4 to the 4th power, so 1, 4, 6, 4, 1 are our original coefficients of each term. And write them really far spread apart because sometimes you don't want to just have to squeeze stuff in there. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Those are the coefficients of each term. Okay, then the first term in the parentheses, right, is a, right? And your first term is going to be raised to whatever the exponent is, whatever you're raising your binomial up to. So a to the 4th, and then you're going to go a to the 4th, a cubed, a squared, a to the 1st, so a to the 4th, a cubed, a squared, a to the 1st, and your last term won't have an a because a to the 0 would simplify to 1, so there's no a in the last term. Okay? Your second term, in this case, is a b. Start at your last term with the b raised to the exponent of 4, and then you go backwards. So b to the 4th, b cubed, b squared, b to the 1st, and then there's no b in the first term. All right. This problem is a plus b to the 4th. There were no negatives. So this whole thing, there will have positives in between. If there were negatives, we would need to take those into account, okay? So let me just write this a little prettier. Instead of 1a to the 4th, that's going to be a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the 4th. Is that what I got when I multiplied it all out on the previous example? A to the 4th, 4a cubed b, 6a squared b squared, plus 4ab cubed plus b 4th, right? Same thing. How cool is that? I think it's pretty cool. That's pretty cool, right? Math. And that was a lot faster. Don't you think?
Yeah.
I know. All right. let's do another one. Let's do a plus b to the fifth power, and then we'll make it a little bit harder. Because if like there's numbers in there, like 5a plus 3 or 5x minus 2y, it gets a little bit more complicated, but still the pattern is the same. Okay, you just might have to do a little bit more work. So example 2, we're going to expand a plus b to the fifth. So this time we use the 1, 5, 10, 10, 5, 1. Okay? So 1, 5, 10, 10, 5, 1. And everything's positive, so we know we're going to have pluses between each term. So in my very first term, what's the coefficient? Oh, I got questions. All right, you figured it out, Michaela? I see that. Oh, never mind. So I'm guessing that you figured it out. All right, so.
Yes, ma'am, I did.
Okay, good. So fifth power, we use the row where the second number is a 5, right? So 1, 5, 10, 10, 5, 1 are my coefficients. My first term is the first term in the parentheses raised to whatever exponent we're raising it to. So a to the fifth. And then I just go in order. A to the fourth, a cubed, a square, a to the first, and a to the 0 in the final, which means there's no a in the last term. Then you look at the second term in the parentheses. It's b. We're going to put a b to the fifth, but that's not going to go in the first term. It's going to go in the last term. And then we'll decrease by 1 when we go to the left. B to the fourth, b cubed, b squared, b to the first. No b's in the first term. And here, everything was positive. So if we pretty that up, instead of 1a to the fifth, we'll have a to the fifth plus 5a to the fourth b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the fourth plus b to the fifth. Coolio? Any questions? Okay, so the next one, we're going to put numbers in there. We're going to put a minus sign in there. Pattern's the same, but sometimes you have a little bit more simplifying to do. Okay, and I'm going to do this on another sheet. So example 3. Same direction, so I'm not going to rewrite them. We have 5x minus 2y quantity cubed. I'm going to do another little Pascal's triangle on this page. I'm only going to go up to 4 degrees on this page, so I'm only going to do it down till we get to the 4. And plus, practice helps. So we know the first level is 1, the second level is 1, 1. Then we have 1, 2, 1. Because we added the ones together to get the 2. When you have 1, 3, 3, 1, that's what I'm going to need for this example, right? And then we have 1, 4, 6, 4, 1. If I wanted to keep going, I could, but I just know on this page, all I'm giving you is up to the 4th power. This one's 3rd power, right? Okay, so we're going to start with writing our coefficients. So 1, 3, 3, 1. My first term is 5x this time. So it's just not x to the 3rd power, it's 5x quantity raised to the 3rd power, not just the x. The 5 and the x is being raised to the 3rd power. Whatever the first term is, raise it to the 3rd power. And then we go 5x quantity squared, 5x quantity raised to the first power. And then we will not have a 5x in the last term. 5x to the 0 is just 1. We don't need to put 1 times 1. Y'all cool with that? Then we start with the 2y, and it's not 2y, it's negative 2y. On the last two examples, everything was positive, so we really didn't have to worry about the sign. But my last term is negative 2y. So when I put that on the end, negative 2y quantity cubed. And then go to your left, reducing the exponent one at a time. So this is negative 2y squared. Negative 2y to the first. And then there's no negative 2y on the first term. All right, let's simplify this. Any questions before I simplify? 1 times 5x cubed. What I do, I know when I multiply by 1, it doesn't matter, but if it's any other number. Would I do 1 times 5x first or 5x quantity cubed first? 5x quantity cubed. Exponents come before multiplication. Now, please tell me, is 5 raised to the third power, is that 15? No, it means 5 times 5 times 5. Do y'all know what 5 times 5 times 5 is? 125. And what is x raised to the third power? X cubed. And I'm going to multiply it by the 1 just to show my steps, but I mean, we know we don't have to multiply by 1. In my next term, I got a lot going on. So we know we're going to be multiplying by 3, but not yet. Let's take care of 5x quantity squared. Doesn't that mean 5x times 5x? Which is what? 25x squared. And negative 2y raised to the first is just negative 2y. And I'll come back and take care of all of that next. My next term of 3, I'm just going to bring it down. 5x to the first is just 5x. What is negative 2y times negative 2y? 4y squared. Times, we know we don't need the 1, but I'm just going to write it. Okay, first of all, negative cubed. What's a negative times a negative times a negative? Negative. And what's 2 cubed? 4. Oh, 2 squared is 4, 8. And then y cubed is y cubed. Okay? Y'all cool with that? So my first term is a positive 125x cubed. My next term, I have to multiply all that together. Do you see how you want some room? Because you want to really have enough space for each term. You don't want it all jumbled together. So let's do our coefficients first. What is 3 times 25? And what's 75 times negative 2? Negative 150. So the sign of this middle term is going to be negative. Its coefficient is going to be 150. And my variables, x squared times y, isn't that just x squared y? So notice the sign, I had to simplify all of that before I figured out what the sign was, okay? Next term, let's multiply our coefficients. 3 times 5 is 15, 15 times 4 is, and all of those were positive, right? So this is going to be a positive term. My variables, I've got x times y squared. We're going to do x, y squared. And since we started with the x's in the first term, x's are going to come first in each term. Last term, 1 times negative 8. And then we have negative 8y cubed. Notice my x's are still 3, 2, 1, none. And then y is 3, 2, 1, none. So if something is squared, you can still use the binomial theorem. You can totally use the binomial theorem. Or I could just multiply it out. I don't know that one way is shorter than the other, but if something's squared, you could still do it. Y'all cool with that one? Yep. Let's do, I have 2 more for you, and I'm not going to make us do the one with a fraction. That's just cold-hearted on Friday before Halloween. We'll do 2 more, and then we'll do assignment next class, okay? Unless you want homework, and we can arrange that. 5x minus y. You want to try this one on your own? It's just to the third power. All right, so try that one on your own. Using the same coefficients as example 3 because they were both to the third power. So 1, 3, 3, 1, and then I'll be quiet. I guess it wrong, didn't I? Did y'all get what I got? 125x cubed minus 75x squared y plus 15xy squared minus y cubed. Yay! Do you have any questions? All right, so we're going to do one more. It's going to be raised to the 4th power, and then we're going to call it a day. Y'all down? Okay. I'll kind of leave that so y'all can still see it in case you need to. Example 5, we are going to expand r minus 3t quantity raised to the 4th power. So this time you're going to use the 14641. Your stuff in that desk, including your phone. Are you just here till the end of lunch? Right, so are you supposed to go back to class? Right. And if you don't? Because you only have 6 minutes. Y'all keep working. I just started mine, but I'm not finished, so let me get him situated. Did y'all get what I got? R to the fourth minus 12r cubed t plus 54r squared t squared minus 108 rt cubed plus 81 t to the fourth. Yay. Again, if this was on the test and you're like, oh, I don't remember the Pascal triangle, just do r minus 3t times r minus 3t times r minus 3t times r minus 3t, multiply it all out. Okay, but this is a shortcut. Anybody have any questions? Yes. Write out the Pascal triangle? Yeah. Yeah, totally. Yeah, you probably would want to. I would write it on my test. Like seeing, okay, I need, she has the highest ones up to the fifth power. I'd probably write it up to 5. And yes, you can definitely write on your test. From memory or from you write, not from your notes, right? Any other questions? Anybody at home have any questions? Don't see any chats. All right, so like I said, we're not going to have an assignment today. On Monday, we will have an assignment over the binomial theorem. No assignment over the weekend unless you did not get what we did yesterday. If you were not here or you tried to log on early before the class, whatevs, then make sure you get that assignment and turn it in by class on Monday. Okay? All right. I'm going to end the video and I will post this video onto Schoology as soon as it's ready.